Be very familiar with quadratic equations. We had a chart from last year in Algebra 2, 5 ways to solve quadratic equations. You might want to see if you can find that. So remember the format for the quadratic equation. It looks like ax squared plus bx plus c equals 0. We can identify quadratic equations because we know that the highest power is a 2. Sometimes we had it in vertex form, so you might see something like a times x minus h quantity squared plus k equals 0. And generally, if it's in this form, we would go about solving it a different way than if it is in standard form. So I'm going to quickly go through some of the different ways we have to solve quadratic equations. One thing I want you to keep in mind is basically we have 3 options. You might have a parabola. If you graphed the parabola, you might have something like this that does not cross the x-axis, and in this case there's no real solution. There's complex solutions when we have that, but no real solution. Or it's possible that the parabola is kind of sitting, or it could be upside down and hanging from the x-axis, and we have one real solution, also a rational solution, or you could have 2 solutions. So that's the situation we're looking at. So we're going to go through some examples on solving quadratic equations. So for the first one, so we're going to solve this first one by factoring, which is one of our methods. This one can be factored with a simple diamond problem. So we've got a product of 18 and a sum of -9. So we're looking for 2 numbers that multiply to a positive 18, add to a -9. So that's going to be a -6 and a -3. Now, since it's just an x squared, then we know the way to get x squared is x times x. So I didn't need to use a box on this. So we're going to have -6 minus 3. Now remember, we had something called the zero product property. We're multiplying. If you remember, if a times b equals 0, then either a equals 0 or b equals 0. So we come over here and say x minus 6 equals 0 or x minus 3 equals 0. So we get x equals 6 and x equals 3. So for our next example, I'm also going to do this one with factoring, but because there's a 6, we do a modified diamond. So 6 times 5 is 30, and my product is 17. Now notice, since both of these are positives, then I know I'm looking for 2 numbers that multiply to 30 and add to 17. So, okay, so we've got 15 and 2. But this time, I can't just put them in parentheses, because if I did and I put x's there, I'm not going to get a 6x squared. So this is the one where we are going to look for some factors out of this. So we've got 6x squared goes here, the 5 goes here, the 15 I'm going to put here. It wouldn't matter which one. One of them's 15x, one of them's 2x. Then I'm going to do GCF factoring. I can pull a 3x out of here, which means this is a 2x, which means this is a plus 5, this is a plus 1. So we get 3x plus 1 times 2x plus 5 equals 0. Remember, you could always multiply this out to show that you do get that. So we have 3x plus 1 equals 0, or 2x plus 5 equals 0. So here we're going to subtract 1 and divide by 3, so we get x equals -1/3, and here we'll get x equals -5/2. Another factoring problem. Now remember, the very first kind of factoring you should always try is GCF factoring, and that's what you're going to do here. So actually this one is quite simple. We're going to factor out an x and have 7x plus 3 equals 0. Go right to the zero product property, so either x is 0 or 7x plus 3 is 0. So this gives us -3/7, and 0 as our solutions. So when we have it in this form, we're going to actually square root both sides. Notice that I don't have like a separate term that's x squared and x. You could multiply this all out, but you'd be doing a whole lot of extra work for yourself. So what we're going to do to solve this is we're going to square root both sides. When you do that, we'll have 2x plus 1, but don't forget it's plus or minus when you square root both sides like that. So we're going to have plus or minus. So that means I have 2x plus 1 equals 3, and I have 2x plus 1 equals -3. So those are my two solutions. So here we'll have 2x equals 2, x equals 1, and this one gives us 2x equals -4, x equals -2. And there's my two solutions that I get for that one. Okay, now one that's a little more complicated is completing the square. So we had a process for that, and I'm going to just quickly go through because again this is review. You have hopefully that chart that you could find and remember, have that information that would tell you what to do. So the first thing I'm going to do on this one is I'm going to move the constant to the other side. So I'm going to have x squared minus 9x plus blank equals 22 plus blank. So I'm going to do this idea of completing the square. And to complete the square, I'm going to take half of the -9, so I'm going to have -9/2, and I'm going to square it, and when I do, I get 81/4. Square the top, square the bottom. So on this blank, I'm going to put 81/4. Whatever I add to one side, I have to add to the other. So now I have x minus, and I'm going to leave it as a fraction, 9/2, quantity squared, because I completed the square now, equals, and we have to do a little calculation over here to see what we get. Actually, I'm going to do this one by, if you get a common denominator of fourths, multiply this by 4/4, you're going to have 88 plus 81, so you get 169/4. Now there is a reason why I actually do leave it like that, because my next step, this problem now is just like the last problem we just did. So my next step is going to be to square root both sides. Well, notice 169 is a perfect square, it's 13 squared. 4 is a perfect square, it's 2 squared. So when I square root both sides, and don't forget plus or minus, I'll end up with x minus 9/2 equals plus or minus 13/2. So now I have x equals, if I add the 9/2, I'm going to have 9/2 plus or minus 13/2. And then I can actually work this out. So we have 9 plus 13/2 is going to give us 22/2, which is 11. And our other solution will be 9/2 minus 13/2. So we end up with -4/2 or -2. So those would be my solutions. Now, completing the square, not the most popular method. Now, I like to complete the square if it's just an x squared and if this is even. It makes it a whole lot easier. You don't have to deal with fractions. So this is not typically one of my favorite methods. I do know that if I got answers like 11 and -2, that means this also would have been factorable. I could have done a diamond problem to come up with that. So that would have been an easier method to do. Some of your homework problems do ask you to solve it by completing the square, so you should give that a try. Okay, here's another one by completing the square. I'm going to actually do this same problem with the quadratic formula in just a minute. But I'm going to go ahead and show you the method for this for completing the square. There is going to be a little time later when we are dealing with circles where we have to do this type of completing the square when you have a number in front of the x squared and it's not a 1. So the first thing you're going to do is factor out a 2, because when we complete the square we want it to just be an x squared. So I'm going to factor out a 2, and I'm going to have x squared minus 3/2 x minus 1/2 equals 0. So factoring out, remember factoring is like dividing, so that's where the 3/2 and the 1/2 came from. Now if I divide both sides of my equation by 2, So if I divide this side by 2 and this side by 2, I'm still going to have it equal to 0. So that's what I'm going to do. So now I have x squared minus 3 halves x minus a half equals 0. Oh, it just changed. Didn't know it would do it like that. Okay, so moving on here, I'm going to move the constant to the other side. Remember what we did next. We did half of this and squared it. So half of 3 halves is 3/4. So I'm going to take a negative 3/4, and because it was minus, and square that, and I get 9/16. Square the top, square the bottom. So I'm going to have a 9/16 here. So now I get x minus 3/4, quantity squared. What goes in the parentheses here is whatever you got when you divided this by 2. Equals, so here we have 8 plus 9 is 17, so we're going to have 17/16 when I find that common denominator. So now from here, I'm going to square root both sides, so I'll get x minus 3/4 equals plus or minus the square root. If I square root this whole thing, so I'll just do this, then we get the square root of 17, which I'm going to leave because it's not a perfect square. The square root of 16 is 4. So then as my last step, I can add 3/4 to both sides. So I get 3/4 plus or minus the square root of 17/4. So there's my answer. Again, probably not the method that you're going to choose, but I want to make sure that you at least practice a couple of those. Here's what you probably would do with a problem like this. The quadratic formula. So I know you all know this. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Yeah, I know you're all laughing, but that's okay. So the value for a is 2, the value for b is -3, the value for c is -1. Extra little minus sign there. So x equals the opposite of b, the opposite of -3 is +3, plus or minus the square root. B squared is going to be a +9 minus 4 times 2 times -1 all over 2 times 2. So we get 3 plus or minus the square root of 4 times 2 times -1 is going to give me a -8, so 9 minus -8 is a +17. So we have x equals 3/4 plus or minus the square root of 17 over 4. Notice it's the same answer that we got with the completing the square process, but the quadratic formula is definitely probably something you would rather use. If you remember from Algebra 2, we actually derived the quadratic formula from the completing the square process. That's why they're kind of linked, and that's why they that's why this works. So that should be a review of quadratic equation solving. Hopefully that is something that helps you to remember what we spent so much time working on last year.